Hey geometry class, today we're going to look at lesson 4.5, proving triangles congruent by, this is called the side angle side postulate and the hypotenuse leg congruence theorem. And that is our goal for today too, that we're going to be using those two things to prove two triangles congruent to each other. Here is the side angle side congruence postulate. It's very similar to how you'd use the side congruence postulate. In that one, you showed all three corresponding sides of both triangles were congruent to each other. Now we're going to be showing corresponding sides and angles are congruent to each other. So here's how it goes. If two sides and the included angle of one triangle are congruent to two sides and the included angle of a second triangle, then the two triangles are congruent. So what it means by included angle is this right here. Look at where R here and U are right here. It's showing that RS and VU are congruent to each other, and then also RT and UW are congruent to each other, and the angle that's being shown congruent to each other cannot be any other angle than the one angle that is in between those two segments, which in this case here is R, and in this case right here is U. So we couldn't show that S is congruent to V, and then these two sides are congruent to these two sides. It has to be the angle in between the two sides that are being shown congruent to each other. Okay, so let's fill this out. So RS is congruent to UV, and R is congruent to U. RT is congruent to UV or UW. And so that makes triangle RST congruent to UVW. Okay, so now let's use this in a proof. Okay, so your example on your page, I had to draw in the correct one. I pasted in the wrong picture, so please scribble it out and draw this picture here for this example. But here we go. Here we are given that these two segments and these two segments are congruent to each other, and they are marked on this picture right here and here. And then it tells us we need to show triangle KJN and LMN congruent. So let's fill in the boxes or the lines here. So JN is congruent to LN. And KN, I'm just copying this up here. KN is congruent to MN. We know that because it's given to us. Now angle 1 and angle 2 are congruent. Well, if we look at this picture, we can see that these two angles are vertical angles. So that's why they're congruent, because of the vertical angle congruence theorem. Whoops. Here we go, theorem. Now that we've shown that two sides are congruent to the corresponding sides of a triangle and their included angles are congruent, then by side angle side congruence postulate, these two triangles are congruent. So here we're just going to say SAS. Okay, let's look at these examples here, and these are a lot like what you're going to be doing in your homework, so follow along please. It says decide whether enough information is given to prove that the triangles are congruent using the side angle side congruence postulate. Well, let's start with number 8 here instead of 7, because this one does actually follow the side angle side congruence postulate, and this is how you're going to kind of show or prove it in your homework. So DK and SK are corresponding sides being shown congruent, so name those. DK is congruent to SK, and the included angle right here and here, name that properly. It's not angle K is congruent to angle K. It's angle DKA is congruent to angle SKT. Okay? And then the last side being shown congruent to the other side is AK and TK. All right. So by the side angle side congruence postulate, because it goes in that order, in either a counterclockwise or a clockwise motion, we have side angle side being shown congruent to the other triangle. Okay, so there is enough information. All right, now let's go back to number 7 here. We have two triangles here, MAE and TAE, that we would like to show congruent, but they're actually not. We can say that AE is congruent to itself here, but if we go in a clockwise motion or a counterclockwise motion around one of these triangles, we would have that angle, side, side are being shown congruent to each other. Well, that is not the side angle side. It matters the order that it is in. So this is angle side side. That is not a congruence postulate or theorem. It is actually called the donkey postulate. And we will never be using the donkey postulate to prove two triangles congruent. Maybe y'all can get that on your own, where donkey postulate comes from. But number 9, well, let's say this, and not enough information. Now, number 9, we can see that we have two sides here in common for these two triangles being shown congruent, and we also can show that angle TMJ and RMJ are congruent, but there is not another side being shown congruent to the other triangle. So there is not enough information. We need another side being shown congruent. So not enough information. All right, so let's move on to the next theorem, the hypotenuse leg congruence theorem. And here it is. It says if we have a right triangle, this is how we can show two triangles congruent. It says if the hypotenuse and the leg of a right triangle are congruent to the hypotenuse and leg of the second triangle, then the two triangles are congruent. Okay? So if you don't remember right triangles and what a hypotenuse and what a leg is of them, let's look at that real quick. So hypotenuse is going to be the longest side of the triangle, or you can look at it as the side that's opposite of the right angle. So it's side opposite of the right angle. Okay? So if those two hypotenuses are congruent on each triangle, and then one of the legs, so either one of the legs can be shown congruent, either this leg AB or this leg AC can be shown congruent to the ED or DF. Doesn't matter which leg, either one of those, then by the hypotenuse leg congruence theorem, those two triangles are congruent. So let's do a proof. Here, we are writing a proof to show that triangle ABC is congruent to EDC. And all of this information up here is given to us. Now I've already got that written down, so go ahead and write that down, because that's our first step in our proof, is to write down the given information. And the second step is I'm going to say, because we know that AB and DB are perpendicular, then right there, angle B is a right angle. Same goes for this angle right here, because ED is perpendicular to BD. Those two are right angles. So we can say that angle B and angle D are right angles. So that's by the definition of perpendicular. Now, on step 3, now that we know these both are right angles, we can say that angle B is congruent to angle D. And that is because both are right angles. Well, so that's the right angle congruence theorem. Okay. And then step 4, going back up to this information that we're given, we have that AC is a bisector of BD, meaning that this line right here is cut in half at this point right here. So, by definition, we should know that these two segments are congruent to each other. So we can go ahead and say BC is congruent to DC. And that is by the definition of bisector. Okay, and step 5. Now we're showing hypotenuse leg here, and we showed that these two triangles are right triangles, and we already know that the hypotenuse of each of them are congruent, and we also showed that one of the legs of each of the triangles are congruent to each other. So, by hypotenuse leg, these two triangles are congruent. So say ABC is congruent to triangle EDC. And that's going to be by the hypotenuse leg. Just say HL. And we're done. So again, let's use what we know about congruence postulates and theorems that we've used so far, including the side, 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 to show that these are congruent to each other. So on this one, we have, we're asked to show that ABC and DEF are congruent. Well, AB is congruent to ED. Write this down. And let's go in the counterclockwise motion here around this triangle ABC. We see that A is congruent to D. And then also this side right here, AC is congruent to FD. So there is enough information on this one. This is using the side angle side. So side angle side congruence postulate. So let's state this right here. Whoops, sorry, dropping my pen. Let's state this right here. Angle or triangle ABC is congruent to triangle DEF by side angle side. And there we have it. Now let's look at this next triangle. These two triangles are right triangles. So let's look at the hypotenuse leg. We have MN, let's write it up here. MN is congruent to RO And we know this side is in common with each other, so ON is congruent to NO. So by hypotenuse leg, these triangles are congruent. So state that triangle MNO is congruent to triangle RON by hypotenuse leg. Now let's look at 12. In this one, you may think that there's not enough information, but there actually is enough information to show that these two triangles are congruent. Because these two triangles are isosceles triangles, we know we can show that this is congruent to itself. And then if this angle over here is congruent to this one, and then this side right here that they have in common are the same length, then we can show that these two sides must be congruent to the other two sides. So we can say that by side, 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 that these two triangles are congruent. And we can list all of those sides together, but I'm kind of running out of time here. So we can say AB is congruent to AD, right? AB congruent to AD. And BC is congruent to DC. And AC is congruent to AC. So by side, 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 triangle ABC is congruent to triangle ADC. But that's by side, side, side congruence postulate. And we are done. So I hope you all understand that, and I will help you out when we get to class and see each other. So goodbye, everybody.